Hi, and welcome to our 19th test and measurement video on today's amazing oscilloscopes. Contemporary oscilloscopes have far more functionality than those of an earlier age. They include built-in instrumentation such as spectrum analyzer, arbitrary function generator, and digital voltmeter. And in addition to these, there is the capability to remember and process signals, connect to the internet, save signals to an external medium such as the convenient flash drive, and more. Right now we're going to look at an accessory, the Tektronix TCP0030A current probe that opens up important new capabilities for Series 3000 and 4000 Tektronix oscilloscopes. Today we'll connect it to a Tektronix MDO3104 oscilloscope and see what we can learn. Traditionally, an oscilloscope is a voltmeter. One or more probes is connected to an external signal or to the waveform from the internal arbitrary function generator, and the signal is displayed. The y-axis is calibrated in volts per division, so that amplitude is shown as a line graph, varying with time. What is measured in the circuit under test and shown on the screen is voltage. Other circuit parameters such as current and resistance can be measured indirectly and calculated using Ohm's law. Electricians troubleshooting wiring or electrical equipment mostly use the volts and ohms functions in their multimeters. At times, however, they need to measure current. The dilemma is twofold. In the first place, it is necessary to cut open the circuit in order to insert the ammeter in series with the load. This is not always easy, and it involves a subsequent repair job. Secondly, all the current that is to be measured has to pass through the ammeter, so to check large loads where the current is on the order of 50 amps or so, special equipment would be needed. For electricians, both of these problems have been solved by the development of the Clampon ammeter, trade name Amprobe. It has jaws that can be opened and clamped around any insulated live conductor. What is measured is not the actual current, but instead the magnetic field surrounding the wire, which varies with the amount of current. A stable reading is produced regardless of whether the conductor is centered in the jaws and whether the conductor passes through the jaws at an angle. The Tektronix TCP0030A current probe is essentially a Clampon ammeter. It is very sensitive, and as a consequence it has to be degaussed periodically. This is because the jaws can act as a permanent magnet and become magnetized. Then any measurements will be invalid. When connected to the oscilloscope, a window opens in the display and it will alert you to degaussing. Simply press the degauss button on the probe and the residual magnetism is eliminated. In doing this, there should be either no conductor in the jaws or an unpowered conductor in the jaws. Moreover, for degaussing to take place, the jaws must be not only closed but locked. Otherwise, error messages rather than degaussing will occur. Now we are ready to use the current probe. As an experiment, we have placed a 1 kilo-ohm resistor in series with a 9-volt battery. According to Ohm's law, the current should be 9 milliamps, but it may be higher or lower depending on the condition of the battery. Also, if the resistor has a 20% tolerance, there is that to consider. Access the DVM. With the current probe connected, the DVM displays milliamps. At first, I got an unstable reading, which I traced to a bad 9-volt battery connector. There are some tricks of the trade. To measure differential current, place 2 oppositely polarized conductors in the jaws. Make sure they fit. Do not force the jaws to close. To extend the DC current range, you can add offset bucking current through a second conductor suitably powered and polarized. You can extend the amount of bucking current by wrapping additional turns of the second conductor around the probe so that they pass through the jaws multiple times. You can take current measurements using the oscilloscope's AC or DC coupling. DC coupling shows both AC and DC components of the signal, while AC coupling removes the DC component. Thanks for watching. More videos on today's amazing oscilloscopes are coming soon. Check back frequently.